name is Jack Leonard. I'll be your host this morning. I'd like to welcome you to HiQA's January webinar on 5 ways to improve your shop floor data collection. I want to go over a couple of housekeeping things first. Before we get started, the webinar will last approximately 45 minutes to an hour. We're going to have a Q&A following as time permits. Any unaddressed questions that are entered during the session will be answered directly via email after we're done. What I'd like to do is I'd like to ask everybody to please raise their hand to let me know if you can hear me and see the housekeeping slide. There you go. And thank you very much, everyone. Question and answers can be entered by hitting the Q&A button that is at the bottom of your screen. It looks like a couple of cartoon bubbles with a Q&A underneath it. We will answer as many questions as we can get to at the end of the session. Now I'd like to introduce our two speakers today. Sam Golan, HiQA's founder and CEO, and Chris Mendicino, our Vice President of Product. And with that, Sam, I'd like to turn my sharing off and let you share your screen to start the presentation.
Thank you, Jack. And let me share my screen. And I will ask for confirmation that my screen is shared properly. Jack, can you confirm that you see my screen? 5 ways
no,
to improve.
we're still seeing, we're just still seeing the names up.
Oh,
not seeing your screen yet.
Let me try again. Share my screen, share. And for some reason, it does not allow me to share screen, and probably now.
There we go. Now we've got you.
Perfect. All right. So thank you, everybody, for taking the time today for 5 ways to improve your shop floor data collection, something that we do on a daily basis, every hour, maybe every minute. I think the question is not about data collection, it's about value. It's not just about the value on the data that we have, it's what we do it when we really need to do something with it. So if we are looking here, and I believe we are all familiar with the Industry 4.0 and Quality 4.0 is a subset. Quality 4.0 is about data, and it is about a lot of data. And it is about a lot of data from multiple resources. But getting data from multiple resources are not helpful at all. If you do not integrate between data sources, it is not helpful if you don't analyze the integrated data real time to provide you a valuable information when you need it. The key is not about the data, but about the useful information, helping you to take a decision when you need it, and not as a post-mortem conclusion, which is many times too late and too expensive. Understanding the gap, okay, that quality industry needs to close to comply with Quality 4.0 and being able to utilize real-time information. Here is a quick example about the challenge. How many data sources we are using to complete a quality process, from 2D print or 3D model to a report or package a submission, where and how all each data source stored, how useful this large amount of data when you need it, and analyze this as an information to take a useful decision when you need it. This data should be automatically available based on our current process now, not when it's too late and too expensive. In more advanced organization, there is a large integration a massive project using platform like SharePoint and ERP to integrate between those multiple resources. But this integrated solution are not just as a metadata, but not about the content, like what we say real-time contact, and about real-time when we need it. Here is another example. There are hundreds of tools types and thousands of inspection tools that are created on a daily basis. How and where all this data goes on piece of paper, in Excel, in ERP system, what do we do with all this data? In many cases, we keep it because we need to keep it. And we use it when customers is complaining or auditors are on our neck. The question is, can we get better value from data collection? The answer is definitely yes, and it will be shared shortly by Chris. Another data source is SPC. We upload results, we have charts, we have X-bars, we have histograms. Do we use it real time? Or in many cases, it is after the fact results, or actually we just keep it and sending to our customers because this is their requirement. This is, I would say that if we go here, and we're going to talk about APQP, Advanced Process Planning. APQP represent massive manual creation of Excel, multiple tabs, and then comes the data collection placed manually on those multi-Excel tabs with actually no real value for us except of satisfying our customers' requirement. In best case scenario, every new project or a new job, we will take current job, we will copy and paste it, and then we will apply massive manual modification. Or in worst case scenario, we will start this Excel project, if you will, of APQP, like from scratch. And APQP consists of all those PPAP, FAI, part submission, etc. This APQP or PPAP, FAI, and other form and documentation, workflow reporting should be an integrated solution. An integrated solution means that you have all form processes and all data-driven, integrated all together. Excel is a great product, but should be out of this equation because it's manual and the data is not stored as in a database structure. So from 2D print or 3D model goes to automated ballooning, inspection plan, all the way to automate shop floor data collection with automated reporting are one application. We should strive to an integrated solution where all quality processes from A to Z are actually one solution. And as our customer, one of our customers used to say before he has this solution that it's all integrated, this is what he says like on a daily basis. I have a lot of data, but zero information when I actually need it. Everything's stored in boxes, in folders, all over the places. And I hope that nobody will ask for any information because it will take me 2 weeks to find it. So that's kind of the pains, if you will, that I wanted to share. And what Chris will share with you shortly, our shop floor data collection, the automation and the value. And it is part of high QA quality management system where we enable companies at any size, small to enterprises, to completely automate their processes, manufacturing quality processes from start to finish, either internally or externally with their supply chain. And with that, thank you for participating today again. And Chris, please take it from here.
Thank you, Sam. All right. I'm going to share my screen here. And you should be able to see my screen okay now.
Before I get to silent mode, we can see it, Chris. Go ahead.
All right. Perfect. So, yeah, so as Sam was discussing, the idea of data collection is really critical to where we're at as within the manufacturing industry. And so not only just being able to collect the data, but being able to make sense of it. And part of being able to make sense of the data that you're collecting is how connected that data is. And so having it in the centralized database all in one place is really key here. And so I want to show you a few different ways that we bring in data from various sources and a few examples of how that's able to be presented and leveraged when you have it all in a centralized database like this. So where we're going to start, the starting point for Inspection Manager is around the ballooning process. So we're jumping right into a part that is already ballooned here through our one-click auto ballooning up here above. And so this one has been ballooned, it's been reviewed, we have an inspection plan. And so I just want to show you an example of what happens when I want to bring in results data from CMM equipment, vision systems, any sort of automated inspection equipment, machines that'll be inspecting parts and giving me results data. So there's a couple of different ways that we do that. The most common method would be what we call our AMDI. It is automatic machine data import. And so that's through this machine sync tab where you can configure your system to automatically import data from your CMMs and VMMs and automated inspection equipment. Okay, so to simulate that here, we're going to go and import a results file against this particular part. So we're in a part record. Okay. We have a customer for this part, some metadata and such, and some dimensions that need to be checked. Okay, so we're going to say import from file. I'm going to grab this example file that I have right here, and I'm going to open that up. So it's going to give me a preview of that file that's being imported. And like I said, typically this would be handled in the background, but through the manual process, we can see some of the options that are available here. Data can be imported against specific manufacturing operations for this part, okay? Specific samples, so if you serialize your parts, or even if you are setting up specific sequences for the part numbers. And we have a whole bunch of other data that we can track these results against. It's essentially traceability information to be able to know what machine inspected this part or generated these results, who the operator was or inspector who ran the CMM, and information of that nature. So I'm just going to import this and you'll see what it does. So bringing that data in, we're able to see visually the results displayed on the drawing directly. So green would be a passing result, red would be a failed result. Okay, and gray would mean that we don't have a result for that yet because CMMs don't necessarily inspect 100% of features, right? And so you can see in our bill of characteristics down here, so this is a list of all the features that we have. So you can see the feature numbers. The yellow is our actuals, okay? And here is our baseline with the types and everything. So nominal, upper and lower, and so on. So graphically, if I'm looking at this drawing, I can select the feature that's out of tolerance here in red, and I can kind of drill into that here. I can see who it was measured by, right? I would see what gauge was used to inspect that particular feature, right? So if it was bringing in that CMM data like so, it would show that data right there, okay? And I would be able to, kind of use this for traceability purposes to investigate what went wrong with that. And also it can populate the reports that we would want to generate automatically. So if we're looking to populate defect reports or any our FAI reports, our standard lot inspection reports, any of that, all of this data is able to be leveraged forward. Here, we can also add NCRs directly from the failed features. Okay, so we're not just launching an NCR report and having to type in all the information about the part, the job, and et cetera. By launching it directly from a feature like this, a failed feature, we're launching it with a whole bunch of information already known, right? So we know the job, we know the part, we know the result value and the serial number and everything that was correlating to this NCR that we're about to generate. So now we're only having to apply additional information like the opcodes and so on. So we can kind of specify things like defect codes to further qualify those NCRs. So I'll circle back to NCRs in a later portion here because I just wanted to hit on it right there. But NCRs typically make more sense to actually initiate from our data collection apps. So that's where I want to touch on next. So we're going to reset some of this here. So I want to show you a couple of things that we have here first before we jump into those data collection apps. So I'm going to work with, let's see, we'll go into this one first. All right, I want to show you some of the SPC side of this first, because one of the biggest things that we can do on the shop floor when we have real-time aggregated data like this is present it in meaningful ways to the operators. Okay, it's one thing for the operator to know what he's supposed to inspect, but to be able to actually see the results and trends and such, they can start to make more intelligent decisions to then prevent problems from occurring, right? And so part of that, I'll show you what's set up here. I have a different part here. We've got a particular job for this part, okay, that the operator is going to be running and inspecting parts against. And we have a whole series of samples that have been generated against this part, okay? And so these samples have unique inspection requirements, so features that need to be checked per sample according to a variety of sampling rules that you can see down here. Okay, so in the bill of characteristics, each dimension kind of is assigned its own sampling rule for how frequently it should be checked, okay? So all of this is able to be set up and organized pretty quickly to be able to feed the shop floor with very explicit instructions for how to, or requirements for what to inspect, okay? So we're gonna jump over to this. This is an example of an SPC dashboard that we might have. And so you can see here how I'm able to see the trends for all of the dimensions that I care about in a particular part. So right here, I'm looking at a specific part number, a specific job, and a group of dimensions that I picked that I want to closely monitor their performance as I'm running production on this part, okay? And so I kind of bypassed over to selection for the sake of time in the presentation here so that we can get into some of the meat, but that is how operators are able to work. And we can even set this up in ways where you can set up like kind of QR codes or barcodes to be able to scan in directly to a particular point like this. You can have operators badge in to clock in to the work. You can see that I'm currently logged in as Chris Mendicino to the app right here, okay? And so they're able to work with a dashboard kind of like this. So each one of these are dimensions showing the CP, CPK, PP, and PPK here. The trend for the previous results that have recently been collected up to the last 30, okay? And it's showing me here green if the feature is capable, and yellow if it's starting to trend outside of capability. You know, it's kind of an early warning, and it would show red if it was actually breaching our capability requirements, okay? So by giving kind of a high level view like this to operators, you know, we can change some of that. We can make things extra small. If we really just care about identifying the colors and which DIMMs are at risk, we may want to investigate that. We can really crunch down the views here to get everything into an easy to read view so I can quickly glance at this. Okay. The other thing here, there are some controls here to be able to view this data on the shop floor, either as control limit warnings or spec limits. Okay, so control limits would be what I just said. So capability, how far is the feature trending within the different Sigma realms, for those of you that understand the SBC side of that. But then spec limits would just be whether or not the feature was in or out of tolerance. Okay, so if any inspection results in the last 30 pieces that were inspected were out of tolerance, it would show me red here. Okay, so just a different way to view the data depending on what you're looking to drive your production off of for preventative maintenance. Okay, and so we're able to click into these directly here. We're able to click directly into these. So if I've got one that's at risk and I want to measure the next part for that, well, first I can pull up and see additional information about the requirement and so on. And then I can click here to then go and measure the additional pieces, input my result, and bounce right back to my dashboard. Okay. So I'm going to show you kind of the measurement process through a different workflow in just a second here, but this is a little bit of a newer flow that we've put in place that we're getting really, really good feedback from. So we're excited about this one. The next one that I want to show you is for a different part. I'm going to put that there, and I'm going to jump over to a different part so you can see what we have in the background to understand the connection here. Okay, so this is a different part that I set up. This part, we defined several manufacturing operations. So this is where if a part is manufactured over multiple stages of process, like see, I just threw some in here. These aren't necessarily meant to be directly meaningful, but mill roughing, drilling, a multi-axis, and then a final inspection operation, right? So each one of these operations, if we go into it, we're building unique inspection plans for that specific op. So we're defining requirements on this end of the application, right? Or this end of the platform. So you'll see there's a unique ballooned print. There is a unique bill of characteristics for this part, okay? And we're able to in great detail specify exactly what needs to be inspected at this operation. So beyond just picking which dimensions, we can add dimensions because maybe there were some DIMMs that weren't part of the finished print. So we can add unique inspection criteria for just this op. We can modify the dimensions that were specified on the finished print. So we've got our finished op up here, but maybe at this stage of the process, maybe this isn't 2 inches on the drawing. Maybe I want to manipulate this and make this, give this some extra stock. Maybe it's 2 inches plus 20 thousandths, right? So I can modify that so that the altered or realistic inspection requirement is sent down to the shop floor for this inspection plan. Okay, if that's the actual material target at that stage. Okay, so we'll put that back for a second. Oh, we'll leave it there. Yeah, let's leave it. All right, so there's a couple of other operations that are in here as well. But you'll notice what I did. I set some sampling rules at each operation. So it's not just about what to inspect, but it's also about how often to inspect. Okay, and so I know this is a data collection webinar, but I think most people that we demo the data collection to, you need some context in order to understand that, right? And so understanding the planning functions and flexibility that we have here is key. So you'll see the sampling rules that we have here. So some of these are 1 per 5, other ones are just checked at the beginning of the lot, okay? And so I've done that for each operation and specified what goes where, okay? And if we look at the samples tab here, you'll see the sample planning that I did as well. So based on those frequencies, we develop our production samples that need to be inspected. So some of the frequencies were 1 in 5, some of them were 1 in 10, some were 1 per lot. So you end up with a sampling plan very quickly. This is automatically generated through a button click earlier, where you say, I've got the first piece that is a full feature inspection, okay, for the first piece in the lot. And then after that, every 5th piece or 10th piece has particular inspection criteria here. So every 5th piece has a few features, and then every 10th piece, I check some more stuff, okay? And that's kind of what's being set up here as a plan. So with that as the backdrop, now when we go to the data collection side, which I should emphasize, the data collection apps are browser-based. They're web-based technologies, so that you can deploy them in a browser. You can have multiple tabs open like this, like what I have here, and that way it's a lighter deployment. So your IT is going to really enjoy that. If you have 300 personnel on your shop floor, they don't have to install a particular desktop client for 300 people. They just distribute URLs that the shop floor personnel can use for that data collection. Okay. But what we're looking at here is a different workflow by which something similar to the SBC side that we talked about, I navigated to a particular part, a particular job and a lot, and now I'm selecting which piece or sample or serial number, whatever you guys use in your own processes. I'm selecting which piece in the production quantity that I want to inspect. And I can kind of see the percentage completion for each of them. I can see the quantity that needs to be inspected and so on. All right, so the first piece having the full requirement, but the next one, I'm gonna click into this one here and just open that up. We'll pick which operation we're working with right now. So let's say I'm working on the mill roughing operation. For this piece, for this specific piece, that's coming out, I only have 2 features that I need to check, okay? And so that's what we're inspecting here. So it's bringing me directly to the features on the print, okay, as I click on them. So this is actually a PDF, or not a PDF, it's a balloon drawing that I can interact with directly, engage with, to kind of navigate around, see what I need to see. So think about the contrast between what happens in most manufacturing environments today and what's actually happening right here in front of you. In most environments, you're dealing with the inspector has to go out to a network share folder and find the balloon PDF and find the Excel spreadsheet and open that up. But having and somebody had to make all of those individual Excel spreadsheets and store them in the appropriate locations and all of that. But this is actually serving up all of that information directly to them in a hyper contextualized manner. Okay. And so, and they're able to navigate easily around between everything. So they're able to see the requirement here and then input their result. So not just the result value. Okay. Here, I'll put in one result for this one. We'll do 0.314 like this. We'll say accept that. So you'll see that it accepted it. It marked that as green, and then it bumped me to the next feature that needs to be inspected automatically. Okay. Now this one, I'll actually record a gauge against it too. So you'll see the gauge category here is vernier caliper. Okay. So if I click to list my gauge, it knows the gauge category that needs that's required for this tool, or I'm sorry, this feature. Okay. So I actually had 2. Yeah, this is a little silly the way I had this set up. I forgot about that, but so I set to just random gauges to have a particular category on this, so ignore that part. But this would show me the gauges that I have for vernier calipers at my particular station. Okay, so depending on how detailed you want to get with the planning here, you can make this very, very simple for the inspectors to be able to say, okay, this is what I have in front of me as options. I'm going to pick this one right here and then input my result that I recorded for it. Okay. Just like so. All right, and then when I input that result, if there's a failure, okay, it'll recognize if it's out of tolerance, which this one happened to be, okay. And then I can say, okay, well, maybe I want to measure that again because maybe I realized that I made a typo or something. But I could say ultimately, well, keep this one failed. Okay. So if I say keep it failed, this is what I was talking about earlier, where we're able to immediately trigger an NCR prompt. Okay, so right now it would display if there were any NCRs previously against this job, it would show me any existing NCRs, but I'm just going to add a new one here, like so. All right, now the key here, again, think about the context of this. Most of the time today, people think of NCRs within their ERP system. Okay, now the problem is ERP doesn't typically have a touch point to the shop floor. Okay, so if you identify a failure that requires an NCR in production or at final inspection or wherever, and you have to generate that NCR, you have to tag the part, which, you know, there's no getting around that. But then you have a paper form or an Excel form or something that you have to go and get. You fill that out with the information that you have, some minimal info, and then somebody else goes and records that into the ERP system. Okay, that's kind of traditionally how this works. But having a touch point directly on the shop floor means we already know a huge chunk of the information that needs to get recorded into that NCR. We know the job, we know the part, we know who the inspector is that's currently logged in. We know the date and time that the failure occurred, and we know which lot we're in, right? So we generate a non-conformance ID. We can immediately disposition it if we have that kind of authority. Depends on your shop environment, or maybe somebody else makes a decision about this through some sort of a review board, right? Now we can just fill this with a couple of supplemental details, like what machine cut that particular part and feature, what inspection centers, so like what area was I doing my inspection at, okay? So we can put all that information in and say, okay. And then here, oh, I actually don't have any defect codes currently. So we'll have to bypass that. But this would be the defect codes that I'd be able to select here. So you have cause codes or reasons why something might happen, right? So I might have, like, if I'm doing like a pocket milling, maybe a chip got under the tool or something like that. Or maybe it was low coolant or bad coolant, or chatter on the tool because the torque was too high on the tool, you were moving too fast through the part, something of that nature that they'd be able to use. You would want to identify common defect codes that occur in your facility, and these are able to be customized. You would have a custom list of defect codes that the operator can choose from to qualify this NCR record, okay? And then they'd be able to say, okay, and move through that NCR, okay? So again, just to cap off that concept of applying a defect code to an NCR record, we're then able to go through Inspection Manager and you can report on NCRs by defect code and be able to see what your most common defects are in the last month, in the last quarter, and so on, to be able to develop continuous improvement initiatives and all those sort of efforts. So that said, let's get back to kind of the raw data here. So as I input the results data against these, you'll see that it's marking them and color coding them. Let's understand what's happening on the back end here. If we go back to Inspection Manager, right? So if we go to the drawing, and we'll go to that operation that we were in. Actually, which op were we in? We're in the mill roughing op right here, okay? And if we go back to here and we're looking at the mill roughing op right now, I want to look at the particular sample that we were inspecting, right? So we had sample 6 is what we were looking at. And we'll open that up and you'll see what it does. I'm able to see in Inspection Manager the results that were collected on the shop floor for that particular piece at that operation, okay? And so I can see these two dimensions were actually critical features. You can see that's why they're a different balloon shape than the rest of the dimensions here. All right, something else that we can specify and give visual cues for. But I can select either of these and just see what went on with them. If I click this one, this had the most information that we filled out, so the failed feature here. Now this one, you can see the gauge that was used, right? We selected that, and we can see who it was measured by. All right. All right, so all that feeds into the reports on the back end as well as having it in the front end app. I want to dive into the gauges here just a second to understand that this is one of the areas where when you're aggregating all this information into a centralized database, it's not just having results data, right? It's having the capacity for NCRs. It's collecting the results from multiple locations and qualifying those results for increased traceability. So we want to know where the sample came from, whoever touched it, what kind of machines it ever was manufactured in or inspected through, and then what gauges were used. So we have a measurement gauges library up here. So if we go to that tab, you'll see I can keep track of all of my gauges that I have in the entire facility across multiple locations. Even the gauges that some companies, some of you on the call even, may supply or provide gauges to your suppliers, and you might want to track those. Okay, so you'll see that out of all these gauges I have, right, I've got quite a few in here. So they could be CMMs or handheld gauges, etc. This is the kind of the attribute data about those gauges, the profile. Okay, and so this is the organization data, so I can see like who the owning company is. That might be you, it might be one of multiple facilities. Okay, and we can track kind of storage places, current place, current user. So there's a whole check-in, check-out system for this as well. Just we'll leave that as a side note that we don't want to get into just now. And then here we're tracking kind of the calibration status and the calibration information. Okay, so this is all kind of intelligently driving all the or qualifying all the data that we're collecting, because it's really critical that if we're supplying an inspection result, we know which gauge produced that result. Okay, so we want to know that the gauge was in calibration, right? We also want to know maybe if we identify an issue. Yeah, we had one of these gauges here. It's one of these guys that we'd used. Here we go. This one and which one here? Let's just go back and we'll find the actual gauge ID, because now I'm forgetting which one it was. So we want this, and we'll see that particular sample. Okay, so it was gauge ID I-039, right? That had that failure. So we'll go back to our measurement gauges here, and we see I-039 that we'll see in here. Yeah, and we can even search for it. If I want to do this, we'll go like this, I-039, if we want to search for the particular gauge. There we go. So that's it. So if we go to the usage history, you'll see that exact result that was collected. Okay. So usage history, now this is going to be a hugely populated list here. This is just showing one result because I'm working with a demo environment, but over time, we keep track of through this tab, it's showing you the aggregated history of every single part, job, lot, serial number, dimension that was ever inspected with this gauge, okay? So it's showing you the result, the actual data. So this one happened to fail. That's the one that we failed out on the shop floor. And we can see which operation it was part of, what the gauge category was that was supposed to be used. Maybe there's a mismatch here and somebody used the wrong gauge, don't know. Who it was measured by and when. Okay, so we're able to see all of that information easily or automatically aggregated into a simple to use list like this. All right, and we can easily filter this by date ranges, because you may run into a situation where maybe you send a gauge out for calibration, it comes back and it failed calibration. And so you need to either make some adjustments or whatever. But if you have a problem with a gauge and you need to look back at the history of what parts were inspected with that gauge in the last week, month, 2 months, whatever it is that you want to go back and kind of double check those parts, you can instantly get to that right here. As you go and you pull up that gauge and you pull up this list to be able to review that. And then you can start your investigation from there to re-inspect those parts and features. Okay. So this is just one of the more significant examples, I think, of highly useful views and information that you're able to derive from the data being aggregated through a single source like this. Okay. So lastly, I just wanted to show one example briefly here of putting all of that data into a report. Okay, so as an example here, actually, let's do this. We'll jump over to this CMM part. So we imported some data through a CMM against this part earlier, right? We had a couple of different samples for that, like so. Okay, so if I want to generate, maybe this is the CMM results data from an FAI piece. Okay, so if I want to generate my FAI report, I can quickly go up here, just say, give me a single piece report, pick which of the two samples. Maybe I inspected two samples, but I'm going to use one of them as my FAI. Okay, so I can pick that. This is similar to the kind of production reporting. If you're going to do a lot production report for a huge number of samples, then you would be able to pick the samples that you wanted to report on, or groups of them, lots of them, etc. And so you would pick the samples that you're reporting on. You would pick the report template that you're using as well. So I'm going to use our default AS9102 template that we have here. And maybe I want to pick specific manufacturing operations that I'm reporting on, and so on. So there's a lot of flexibility here for the filtering that you could apply. So we're going to create that report for that particular piece that we have. And no. Okay, so the report ends up right here, where you would have all of your reports aggregated and stored. And I apologize for that. I forgot that I was testing something on this system, and my Excel is disconnected from this particular instance. So I don't have an example of that report right now that I can show, but that's how easy it is to be able to generate the inspection reports and keep them stored in an aggregated database, right? So if you've seen any of our other demos, any of our other webinars, the flexibility in our reporting is quite high. And having them stored, again, this is centralization of information, right? So it's not just the data that's in the database, but also the files, the reports, when you're dealing with things like material certs that you want to upload against the job, right? So material certs are able to be aggregated as well in here, so that you come to one place for the part, the jobs, and to be able to see all of the quality related information that was collected against those jobs, right? So there's no more hunting around through folder hierarchies and Excel files, PDF files, and having to kind of search for what you're looking for. This is basically an auditor's dream, to be able to have everything aggregated into one location. And beyond just aggregating it to one place so it's easy to find, if things are easy to find, that means they're also easy to analyze, compare, contrast, and report against as well. So that's, I think we'll end it at that point, and I believe we're going to open it up to Q&A. Jack?
Absolutely. Chris, if you'll check, and Sam, if you'll check the Q&A box, you'll
Yeah,
see that
before
we
we
have a few
jump,
messages in there.
yeah, one of the things that I got kind of an offline from one of the people there, Chris, can you touch shortly on the the flexibility of data collection from different machine, CMM, VMM, whatever, if you didn't yet, and how
yep,
when we have the preset set up. So yeah, go spend like 2-3 minutes and share your screen again and share with us. Okay, thank you.
Yeah, absolutely. We can hit on that. Yeah, that's a common question. Is that's great that we can import data from CMMs, but what's the flexibility there and so on? It's basically the nature of the question. So the way we import data from CMMs is through results files, like data type results files. So it can be Excel, CSV, text, .dat for some of them. But these files are able to be configured for the types of data that you want to use for traceability purposes and so on. And we have a highly capable, highly flexible import engine that allows us to build essentially import templates. So that's what we call presets. So we have this thing here called a preset library. And I'm able to see here a couple of different things. So I just happen to have one out of the box. This is something standard with the system, a preset, and I had one that I was working on for a customer earlier that was a PC Demas preset. So you may have a few in here that, let's say PC Demas, Zeiss, Calypso, mCosmos, any CMM programming application. So you might have a few depending on what types of CMMs that you have to work with. Okay, and so what that does is once we set up the automation for the different folders that you're going to use for importing the data. So almost every CMM application like PCDMIS or anything you can set up default folders that you dump the results data to. And so we would just monitor those results folders and automatically import any files that are dumped into those folders. Okay, so the files get imported and associated with the correct part, rev, job, lot, manufacturing op, and serial number. And so, and then we can have all the traceability information tied in there too. So that's something that we work with you on to identify what sort of information you want to track, how much automation do you want, and so on, to be able to kind of configure the environment per your requirements. So it's part of our onboarding process and part of the implementation that we work with you on that area.
Perfect. So, Chris, couple of questions that you cover, I will cover. In my process, we don't have repetition of manufacturing parts of the same part number. Each part is new design, but the characteristics are repeated. In this case, the software can generate the SPC from the characteristic instead of a part.
Trying to make sure I understand that question.
Me too. That's why I asked you, because it was not completely clear to me. But this is Francesco, I think, Kona.
Yeah, it sounds like a very unique use case having
So
to
we
do
can
with
do
like a
it.
prototyping shop. I think they're
Probably, right.
prototyping parts, so there's not any degree of volume.
But maybe
yeah.
the characteristic is the same. Like, so you can set up as an.
Yep.
But we will answer it, and we'll try to connect to Mr. Kona or Chona one-on-one and try to get it,
Yep.
more detailed. Oh, the same question from this gentleman. Is the software available in other languages? In Portuguese. We are supporting many languages. Trying to remember if we have Portuguese. Yes, we do.
Yep.
Gonna,
yeah, we do have Portuguese.
Yeah, we do. Let me steal your screen sharing for a quick second. Can you? I'll take the screen. Okay, let me see that I can share my screen. And this is for Mr. Kona, but everybody. You can see my screen, Chris?
Yes.
The high QA. Okay. So clicking here, you can see high QA languages. It's a lot of languages, but you can see here Portuguese. So Spanish, Portuguese, Chinese, Italian, Turkish, Japanese, Hindi, So yes, there are multilingual software. What is here? Okay, I'm trying to kind of scroll down. This software available in language? Yes. Can we switch on off SPC rules on SPC dashboard? Like turn. Can you see this question, Attila?
I can. Yeah,
Konya?
I would. Yeah,
this
I'll
is
take
also
over
something.
I'll take over the screen share again.
Okay, please do.
Yeah, if you want to close out your screen share.
I do.
Yep. All right. Let's see. So Yep. So someone was asking, can we switch on off SPC rules on the SPC dashboard, like trend, run, etc. So the SPC parameters, I'll show it on this end. It's a little different between here and what's on the shop floor side, but this concept is similar. So the way the SPC works is here. I'll jump into that part that we had. Is you're setting up kind of your SPC, like your sampling rules and such, but you're also defining which ones you want to monitor over time and what your target CPK and PPK values are. Okay, for each dimension, you're able to specify that. And then on the dashboarding side, you can, like as an example here, so this would be an SPC dashboard, right, where I'm able to filter and such, and I can expand on this. So this is a little bit more comprehensive than what's on the shop floor side. It lets you dig in a bit more to see more statistics here. Okay, and you can do some advanced SPC reporting off of this to be able to generate whatever types of trends or statistical analysis you'd like to do on the data. We can work with you on configuring some of that. All right.
Okay, good. There is a question from Cesar about how long I'll be able to use the application. Probably you ask about the demo application. We can talk to you directly. I think you are from Brazil, FMC, which we are working right now with your head office, I think. So we'll take it offline, but we will communicate with you directly, Cesar, about it. Carrie Scott, can this be integrated with ERP system to populate requirement for particular job part? The answer is absolutely yes. We have an API, 2 layers. One is the basic, like job part, job number, part number, delivery date. And then we have a very robust API that can integrate in much intimate level, if you will, not just with ERP, but with PLM or any third-party application. And it's done via API. I would like to down the demo application.
Yeah, that was the same
we'll
person.
talk about it. Okay, Bill Bryan, can you tell us more about leveraging model-based definition to automate the creation? So I can talk a little bit about it. We support model-based definition, 2D and 3D. And our model-based definition is, I would say, significantly different from what you know, because to bring model-based data is, I would call it not a very, complicated stuff to do. But to bring it with the all PMI, we enable users to modify, adjust the model with the PMI, because with the PMI, there is a lot of non-relevant data that brought in. We enable creating views based on the MBD. We enable to export the native file into step file so it can serve you outside of the MBD for your other stuff like NC for the chem process. We can convert it to a 3D PDF in one click. But the biggest thing is that once you are ready, you push the button and all this information, all the model with view in the PMI converted automatically to a 2D view. It's like you created it from a 2D print. And from that point, you can apply all your inspection quality processes like you do today with 2D, which is more trivial and correct. For instance, let's say in process inspection, and Chris showed. So you can create in process inspection, you can assign inspection tool, you can assign inspection plan, reporting, data collector, and SPC. So the idea is that MBD is automatically converted with all the PMI. You have the option to work on the model, modify, adjust, clean, prepare, and then in one click, it's converted into a 2D with all the bill of characteristic and ballooned automatically into the database. And it's Bill Barron. We will be very glad to communicate and share with you or anybody else how our AMDI model-based definition works. Can we run gauge RNR? Yes, we can. We can talk about in more detail one-on-one. For an example, Jason Sears, a milling machine with multiple positions and pallets. How does your software handle SPC chart when your sum dimension is okay?
I can take that one.
Yeah, sure.
Yeah, so when it comes to SPC, you're wanting to basically compare similar situations, right? SPC doesn't mean a whole lot if you're comparing parts from totally different pallets or fixture setups or different machines, et cetera. You want to compare apples to apples to understand consistency or even variation between two different setups, right? And so that was something that I was hitting on, is that when you're importing the result data, being able to understand which samples were created or manufactured within different setups is critically important. So you can qualify samples as being set up on a particular fixture or through a particular machine center and so on. So the easiest way to do that is through like CMM inspections, because that data can be automatically generated. And so we'd have to take a look at the use case that you have there for how you want to do that. But the important part is being able to filter the SPC by specific criteria like that, so that you can identify variances between the different scenarios. And that's something that we can do quite well.
Okay, so I think we have here another question about, you can take it from Carl Enklem. I have several similar families of hydraulic manifold. Anything that you would like to address here, Chris?
Yeah, I'm just reading it to understand it.
So I will jump to another question. There was here, can high QA software, oh, okay, import export data into from ERP, just talked about it. It really doesn't matter what ERP that you have or any third-party software. It's API to API, application programming interface. We are, as we speak, without getting into names, but we are doing tight integration with SAP. And that's a process that we handle with the customer, mapping the field, the processes, what needs to be communicated in between ERP or our system or PLM, if you will. The question is not about the integration. We can integrate everything. The question is the value that we would like to get out of this integration. And this is what we do, kind of process mapping together with the customer, talking about the value. Do we need to get data? Do we need to send data? And it's bi-directional, of course. By the way, we did 3-directional at this project that I'm talking about, because it's between PLM, ERP, and our system.
I just want to break in here for a second. We are coming up to the top of the hour.
Oh, wow.
And
Okay.
we realize that some of you may have hard stops at noon Eastern time. If Sam and Chris are willing to continue on for another 5 minutes or so, we can try and answer a few more questions.
Let me, I see Jason Sears. Can you show us more features on the IM Explorer SPC application? I mean, there is a lot of functionality on the SPC. The Explorer, and we will do it. I think the better to do is like stop it in 1 or 2 minutes, and then we will communicate with any requirement one-on-one, which more detailed demonstration. But the SPC start or works on tablet or PC, and the whole idea is that you prepare it on the inspection manager application, and then anybody on the shop floor, either specific person or department, get all this requirement directly into the shop floor. We are converting every paper activities to a complete paperless. And from that point, data can be collected from manual tool, wireless, Bluetooth, wired tool. And when the data is entered into the system, it's real time in the database. That's what we talked about, real time data collection that provides you all the value real time. The system can trigger alert if there are out of tolerance feature. The system can open immediately, automatically, what we call internal OCR, sorry. So it's integrated and it's automated. And what we will do, we will communicate directly with every person that, or every company here that would like to see a detailed demonstration, and we would like to share it, what we call one-on-one.
Yeah, Sam, the rest of the questions I'm kind of going through, I think are specific use cases related to very specific use cases. So I think it's great to follow up and answer those through demos.
Oh,
There
yeah.
is one last question that I see that is generally applicable, I think, to the majority of the audience here. Carrie asked, does the drawing in the database maintain any legacy information for revision changes to drawings? Could the software replace the need for separate document control software specifically for balloon drawings? The answer there is absolutely yes. The system can be set up. You can have your active parts and jobs that are currently in process, and then over time you archive them so that they kind of are out of the way of the active queue. But then parts, we have a detailed or sophisticated revision workflow here. So I believe I'm still sharing my screen. So
Yes, you do.
Yep, so you can queue up a new part revision and then update drawings. So you're not having to re-balloon or rebuild inspection plans from scratch. You're simply leveraging the existing inspection plans and balloons forward into a new rev. You copy the part, so you have full history of the of all the different revs and all the different jobs that were run under each rev, all of the sample and results data that was collected under each part rev, and so on and so forth. So yeah, it's an extremely robust system in that regard.
And for Robert Epker, Bob, I'd like to send our presentation, your presentation, to a colleague. How can I get it? Each one of you will get an email probably by tomorrow. Definitely thank you for taking the time today, with a link to the whole webinar. And you are very welcome to see it again and share it with your colleagues, friends. So you're gonna get it, all of you will get it by tomorrow, correct, Jack?
Absolutely.
Okay, so from my side, Sam, Golan, and Chris, thank you for taking the time. Jack?
All right. I'm going to take the screen share away.
Sure.
And put the couple of slides back up here. So I want to thank you for attending today. We have a couple of upcoming webinars. Thursday, January 21st, our monthly Ask the Expert open Q&A session. That's at 11 o'clock, and you can register for that either by using the link that will appear in your recording tomorrow, or going to highqa.com/news and look for the events and webinars. We also have another webinar coming up in February 10th, MBD, Meet and Learn Community. This is model-based definition, Meet and Learn Community, an update from ASML and HighQA. This is a follow-on webinar session to one that was done in 2020. And the registration information for that will be available shortly. We actually ask you to visit our news page on the website or our homepage, and you'll find more information about that as it becomes available. And with that, just thank you for attending today. And we look forward to engaging with you on discussions about your manufacturing quality process and workflows in the future. Thank you very much. Have a good day.